Okay, the 9700 is finished. I have to retest it on 120 volts instead of 240. This transformer here just was not keeping up. I was going down to 230 volts. Even still, at a 5% under voltage, it was producing 220 watts per channel. Let's see what we'll get when we retest it on 120 volts, and just to show everybody that it's not collapsing too much. That's it driven deeply into clipping. So that's good. And I still had problems with voltage drop. This is actually using a very thick extension cord going to the kitchen instead of the outlet at the bench. It turns out the wiring in my walls is a bit on the thin side. Yes, this thing is capable of drawing that kind of current. Okay, we're testing at 20 Hertz right now, into 8 ohms, both channels driven. This is just a little under 1 watt of power, and we're at about we'll call it 0.7 average THD plus noise. As you can see, the measurement is THD plus N, and that's at 20 Hertz. Now, let's see how much power we can get. Again, both channels driven into 8 ohms. And we're going to look for the point where the distortion just really starts to go up. Whoa, that's a little high. Let's see. 44.7 volts. What's that? Let's go to our good old TI-89 here. 44.7, whoops, squared, divided by 8 ohms. 249.761 watts per channel. We'll call that 250 watts per channel. Not bad for a 200 watt amp. Not bad at all. Especially considering that I did that in 20 Hertz, which is the most stressful for the power supply. Now let's try 1 kilohertz. Change our source. Change our frequency to 1K. Amplitude 1 volt, that's correct. Alright, let's see the THD plus N at 1 watt. Most of your listening happens at about 1 watt or less. The extra power is going to be there for freedom from distortion on the peaks. Oh, beautiful. 0.05 THD plus noise. That's nice. Especially at a watt, where noise is more of your signal than the distortion. How much power can we get at 1 kilohertz? Whoops, little much. About the same. About 250 watts. Now, the real stability test happens at 20 kilohertz. A lot of amps that aren't quite right really misbehave at 20K. So, we'll change the frequency to 20 kilohertz. Often a little touch on the noisy side here, but this is the least stressful for the power supply. And not very noisy at all. A little under 1 watt of power, and we're still getting, in some cases, better than 0.05 THD plus noise. That's really good. Let's see how far we can take it. Oh wow. And it didn't like that. Overpower kicked in there, but less than 0.03. I saw 0.02 something there. Yeah, 0.025 at 45.6 volts. Good grief. That's amazing. Alright, 45.6 squared divided by 8 ohms. It's about 260 watts. That's very good, very good. We'll take that. And again, at just a little, about a watt of power, you get excellent THD plus noise performance. This amplifier is fixed. Actually, it's better than fixed. It's amazing. For those that want to see what the load banks look like, they're just some very large resistors. I'm 5'11" or 181 centimeters tall, so fairly good sized hand there. These are fairly good sized resistors, and they're too hot to touch right now. They're really hot. You can actually smell them. So this guy put out a lot of power. And double check the accuracy of the meters here. Yep, right at 40 volts we get the 200 watt segment lit on both channels. Those were not that accurate to start with. I had to calibrate them. The calibration adjustments are down in there, in that well there. Some European specific tuning will be done. First off, we're going to set the voltage back to 240. Customer says it's 220 in Sweden. I'm going to set it for 240 just in case we get an overzealous customs agent that wants to plug it into the mains. I don't want anything to happen to it. And also, there is a question in Sweden whether it's actually 220 or 230. I would encourage my customer to measure his mains. It may be 230. The EU is harmonized on 230 as the standard, and it's kind of weird. The tolerances allow 220 or 240 in the EU to accommodate older parts of the grid in mainland Europe and, of course, the UK before they decided to leave like idiots. The other thing you want to take a look at is the FM de-emphasis switch, which is on the tuner here. See if I can focus in on that. One setting is 50 microseconds de-emphasis, the other setting is 75, and I believe in Europe it's the 50 microsecond setting instead of the 75, and that's what I've placed the switch on. If the FM sounds a little strange to you, wherever you are, you might try flipping that switch. But anyway, that's a wrap. I'm going to put the lid on here, put the 6 amp fuse back in, and set the voltage for 240. There's actually a little note here that says you should use a 12 amp fuse for 100 or 120 volts and 6 amps for 220, 240. And you'll want to make sure you change the fuse when you go to a different voltage, otherwise you'll end up with, in the case of 120 volt systems, nuisance blowing, or in the case of 220, 240, you'll end up with a loss of protection for your transformer, which could be dangerous. But anyway, the voltage input to the amp at full power was 119 volts, which is good enough. So this thing is capable of quite a bit more than advertised power. I'm very pleased with this. Some people have wondered, including the owner, why I didn't do a test before all these renovations and repairs. Quite simply, it wouldn't have survived it. It would have blown up. We would have seen smoke and quite possibly tripped a breaker and lost some of those shop lights. It's just not safe to do these kind of, well, in some cases, downright abusive tests to a receiver or amplifier that hasn't been restored. It's really, really risky. and I don't do it here for that reason. Could have made me a lot more work. But anyway, it's done, and now it's time to box it up.